Okay, so I'm going to try something new here. I'm going to try to do some video lectures to assist with the course. Of course, these are just, one resource, and I encourage you to continue to ask me questions or to go over whatever you feel like you want to discuss with me. Um, but the first section here is Introduction to Programming Languages. And what we're going to talk about with this lecture is the layered architecture in computing. So the language we're going to use this semester is Python, a high-level language. Um, Python is considered a third or even a fourth generation language. And below that is something like C, which is a little bit lower level. It gives you better access to the operating system, better access to some of the internal resources, while still not really needing to keep track of things in registers or memory. C does a lot of that work for you still. Below that is assembly language, which does not do that work for you, and basically requires you to keep track of every individual bit of your program, where all the instructions are in memory, where all the data is in memory. And below that is binary code. That is the stuff that actually runs on the hardware, on the machine. And of course, the hardware itself, which are silicon circuits where electricity runs through and triggers certain events based on whatever is in the binary code. Okay, so let's take a look at these different types of languages just to get a sense of it. Here's some basic Python code, and I'm going to pause briefly here while you look at the code and just try to figure out what it does. Okay, so after looking at it, I realized that wasn't a terribly long pause, but you can pause the video too. Um, so it sets some prices for apples and bananas. This is actually a Python dictionary. Then it has another Python dictionary here, which indicates the quantity of purchases. So 1 apple and 6 bananas. Okay, and then it does a sum of the prices times the quantity, and stores that grand total in a grocery bill. And then it prints out in some formatted fashion the amount due. Okay, so basically what this does is it takes a grocery order and figures out what the total of that order is. Okay, so here's it's a completely different program in C code. Okay, so you can see in C, okay, that things are a little more complex. So I'm going to again pause for just a few seconds and let you try to parse through this code and try to figure out what this code does. Okay, so if I look at the C code, okay, I have to include a library that is the input and output library. That allows me to read and print things in C. Okay, I don't have to do that in Python. Python just automatically knows how to print. Okay, I define a variable last, okay, which is a named constant in C. Okay, then I set up 2 new variables, int and sum. Okay, and basically what I'm doing here is looping through from 1 to 10 and adding those numbers to the sum and finally printing out the total. So I'm adding the numbers 1 through 10 and printing the solution for that. Okay, so this is a much less complex program in C than the Python program, although it takes more lines of code, okay, and is a little harder to follow. Okay, so here's some assembly language code. Okay, and try to ignore this stuff here, but don't worry about it too much. Okay, again, I'm going to pause and try to let you figure out what this code is this particular section of code is doing. Okay, so this one's a little more, again, a little harder to understand, a little more esoteric. Okay, what this does is print out Hola Mundo, or Hello World in Spanish. And so really, something that would be one line of code in Python, or, a few lines in C, now is a lot of lines in assembly where it's not even really doing any looping or calculating. It's simply printing something out, something that's hard coded in its main memory. Okay, so again, much lower level code. Okay, and here we are at the binary code level. Okay, and I'm not going to dwell on this because this is a little bit of a trick question. Okay, each of these commands actually isn't even a full program. It's just a single command within a program. Nobody actually writes things in binary. Okay, so one thing that's useful to understand is the difference between a compiler and an interpreter. So languages like C are compiled, C, C++, Fortran, assembly language is assembled. But you start with source code in plain text format. Okay, you run things through a compiler, which generates machine code, which can then run on the operating system. Okay, and produce whatever output your program creates. Now, the nice thing about this is once it's at the machine code level, okay, you don't need to have any other software installed on the machine to run it, and that executable would run on any machine with the same architecture. Okay, for an interpreter, okay, the source code again is written in text. Okay, so here it would be like C code gets compiled, creates an executable, and then can run. Okay, in Python and Java and a few others that are interpreted languages, okay, you have source code that gets input into an interpreter, okay, which essentially runs the program in real time. So one of the oddities of this is you can have your Python program run and it will suddenly stop. It'll run partway through and then it'll stop when it encounters an error. Okay, as opposed to compiled code, which will tend to run through to execution whether or not it has an error. Okay, interpreted languages are a little slower typically, but much more portable. Okay, so now you can take your source code, okay, and run it on any computer that has a Python interpreter on it. So you don't need to have the same, the machine code dedicated to the architecture of the program. Pardon me. Okay, in both cases, okay, the source code starts off in plain text, and we'll be using something like, pardon me, Atom or Sublime or Brackets or, PyCheck or whatever your favorite Python interpreter is, or source code writer is. Okay. And so keeping in mind that, source code should be just something that I should be able to open in any file, any text editor and be able to see, as opposed to something like Microsoft Word, which is not a plain text editor, okay, and it keeps things in its own esoteric binary language. Okay, so Python as a programming language, okay, it's a high-level language, relatively recent, 1989. Realize that doesn't sound recent to you, but it is. Okay, it's an interpreted language, and it runs on pretty much any platform. So a PYC extension indicates that you've got compiled byte codes, okay, which is not the same as a machine language. Okay, but it is something that the Python interpreter can understand. Okay, and the takeaway is that it's a general purpose, object-oriented, interpreted language that has a lot of really powerful features that are very useful for getting things done quickly. Okay, we're going to use Python 3.7 or higher in this course. Okay, so just make sure you have that level of Python installed on your machine.